Hello, welcome to Tech Talk with Steve. Years of installation, design, estimation, project management skills in the ICT industry. And that's right out at the end of my cord from my permanent link adapter.
But we did win this great award for Test Pros.
So I've connected my tester here. This is my remote. I've got the plug from the modular plug terminated end of the link. He opened Wilson Technology in 2004. He brings 50 plus years of telecommunications and information technology. Hello, welcome to Tech Talk with Steve, episode 45, another RCDD Roundtable. Got a couple RCDDs joining me today, and we're going to be talking about cable management in the installation, as far as supporting the cable that's installed, even while you're pulling, when it's at rest, things, do's and don'ts about termination and what to do when you're pulling it in. Things that, maybe should be common sense, but a lot of times get overlooked. And I've got a couple of very special guests that are joining me to talk about this today. First up is Chuck Bowser. Chuck is not a stranger to Tech Talk with Steve. You saw him in the intro there in a couple of different shots. He's got 40 years of installation, design, estimation, and project management skills in the ICT industry. He leverages his knowledge to help educate and enrich the lives of his peers. As an instructor and host of Let's Talk Cabling podcast and vlog, Chuck brings weekly content across all social media platforms in a manner that anyone can relate to. He holds the BICSI RCDD and tech credentials and is a volunteer member of the BICSI Standards Committee. Welcome, Chuck. Next up is Dave Landfair. David Landfair has been associated with the structured cabling industry for more than 38 years, and I think he and I have known each other for about 30 of that. He's got a focus on cable connectivity and data cabling pathways during his years of experience. An experienced presenter to engineers, end users, and contractors on the subject of data cabling pathways. He's presented at several regional and national BICSI conferences. Dave's an active member of BICSI and serves on 2 different committees. He has held the Registered Communications Distribution Designer, RCDD BICSI credential since 1995. And he's preparing for the Data Center Design Consultant BICSI credential. He was the 2019 recipient of the BICSI Harry J. Pfister Award. Currently, David is the Senior Regional Sales Manager for Invent Caddy for the Southeastern U.S. and is focused on the low voltage market for Caddy products, which include a recent Invent acquisition of WBT wire basket tray. He has held positions responsible for sales and business product development. He's married to Kathy and is a regular church and community volunteer and an avid kayak fisherman. I don't think I knew that. Welcome, Dave. I didn't know you were an avid kayak fisherman. That's great.
I've got a fleet of kayaks in my barn. Come to Florida, I'll take you to some really cool places.
I've got 3 or 4 in my garage, so we'll talk.
Great. Well, welcome to both of you. It's good. We saw each other at BICSI. It was good to catch up there. Always good to see you guys. And I figure we can kick this off. Dave, you've got a lot of experience in the management of the cabling when it's installed. What's supporting it, even as you're considering installing it, where you're placing these supports, things like bend radius and congestion in the raceway, things like that. So I'll let you start off and let us know what are some of the pitfalls, what are things we got to look out for, and of course it's all going to come back to testing. We'll talk about that at some point too, because if you don't do things right, it's going to show up in your test results.
Absolutely. And it's interesting that, from an end user and engineer perspective, many times focuses on which brand or type of cable to use, which brand or type of connectivity to use, looking at the racks and the cabinets and that type of thing, but not nearly as much focus is put on the pathways themselves. A number of years ago, I wrote a Bixby article, and the premise was comparing the cabling infrastructure to racing and car racing. Some racetracks are a category 5E racetrack, like a Bristol. It's a real tight course. You're not going to get very much high speed there. But when you look at a Talladega or a Daytona, those are high speed racetracks. Those are your 10 gigabit tracks. And so the cars that run on those tracks are not the same cars that run on a gigabit track, if you will. And, the tight turns are not good for high speed performance. And you just can't do it. If you try to, that Ethernet packet's going to go off into oblivion, so to speak, just like
it'll hit the wall.
It'll hit the wall. And so, you really have to think about, as the speeds get better, the cable diameter gets a little bit bigger. You've got to think about better pathways, a little bit wider, gentler bends, so to speak, to maintain the 4 times OD bend radius requirement under 568.
That makes absolute sense. So there was a time when, back in the 90s, I can remember we used to call them trunk slammers. They literally, they throw a spool of cable in the back of the car. And Chuck, I think you've used that term before too. And they'll go in and they'll just pop a tile out of the drop ceiling. They throw it across the drop ceiling, maybe tie a Coke bottle to it and, toss the pull string over. They just yank that cabling across the ceiling, leave it lay there, terminate it, and they call it good. But we can't do that. Not and expect it to perform well, and not expect it in some cases to meet code, let alone standards, right?
Absolutely. It's, under the standards, maximum of 25 pounds pulling tension on the cable, maintaining the bend radius, not only when it's laying there, but really more importantly, as you're pulling the cable into place, using pulleys to go around corners and, not getting a lot of friction between the cables as you pull it. Because any deformity or any changes to the way that the pairs lay within the jacket can affect the performance. And you obviously would know that very well with the testing. You can take a cable and move it around and adjust it, and you can change the performance of that, the throughput, very easily.
Yeah, go ahead, Chuck.
I was going to say there's some tools out there that can help manage the pathway as well. You kind of already mentioned one. Gennard sells the pulley wheel thing that you can attach, but there's this thing called the ceiling stingray. Gennard makes also one similar to that as well, so that when the cable's going up, it doesn't scratch across the edge. But the biggest areas that I see that most techs just don't think about when they talk about managing your pathways and stuff is you got to think about how you're going to address the closet. Now, I just did a roundtable last week with 3 of the best cable dressers in the industry, and they all said in unison, you got to think about how it's going to come in and dress across while you're pulling that cable, right? And then another one you got to watch out for too is safety, right? Even though you may not be the one installing that support system, your cable's going to be laying in it. So if another trade put it in, you really got to make sure that they did it right and per code, because if it fails, you know how litigious everybody is nowadays. They're going to sue the cable tray manufacturer, the people installed it, you, because you put your cable inside of it. So it's up to you to make sure that not necessarily fix it, but identify when there's something that's not done right. And those get often missed when you're talking about managing pathways.
And all of these things, a lot of times when a test fails, the first thing I think of is, I terminated it incorrectly. I didn't maintain my pair twist, or I skinned back too much of the sheath, any number of things that could have impacted it. But there's so much more going on that you mentioned, the dressing, everything that supports it along the way. Not having a sleeve that allows you to pull without grinding against a sharp surface. You could damage the cable during the install, and as David mentioned, change that geometry of the pairs. You could actually damage the jacket. If it's a shielded cable, you could damage the shield, and maybe not know it until you run a test and you start seeing problems. Or maybe it passes the test initially, but down the road they're having problems running data because they're getting noise in there because you've damaged the shield on that shielded cable. So any number of things could happen.
Yeah. Or they upgrade it to a faster network, right? And now all of a sudden it's sensitive to stuff. And we didn't even talk about if you have a cable tray with the rungs, if you overload them, the cables on the bottom are getting crushed, and that deforms the physical relationship of the pairs inside the cable, and that'll show up hopefully when you test it.
Yep.
Yeah, Chuck and I were talking about this recently, and education is really critical for all levels of the installation management personnel, from the cable puller to the project manager and above, all of the points in there. And really, education, it cannot be overstated for at any level, and it really needs to be encouraged by the installation companies out there to have their people make time for them to learn and take advantage of certifications that are out there in the industry, whether it be for manufacturers or through Bixby or whichever, but utilize that education opportunities that are out there.
Yeah, it's that's really every facet of what the people in our industry do. That education is critical, and Chuck talks about this all the time in his show. It's whether it's the installation technique, whether it's how to use your test equipment, underground wire locators. I used to teach classes on how to use those, and the most common thread when people have problems is they never read the manual, which granted, most guys aren't going to read a manual anyway. Yeah, Chuck, I know. But
manual? What's this thing you talk about, an owner's manual?
Right.
What's that?
But worse, they've got the opportunity to get training from the manufacturer of the product, and they don't take advantage of it.
Right.
And it's critical that you get training on whatever product you're doing, whether it's test equipment or some kind of installation gear. Cable puller is a good example. If you're using a mechanical cable puller, make sure you educate yourself on it and make sure that you know the do's and don'ts, because that's the single most dangerous thing that you can do in our industry is using a cable puller if you don't do it right.
Right.
You use the wrong pull rope, things like that. People can get injured or worse. So
when you're talking about education, Steve, the probably the most dangerous thing for as far as education is when somebody teaches you how to use something very complex like a tester, and they didn't get the training and they're doing it wrong. So now you were trained wrong, and then now you've got this to set in your mind. When someone tries to teach you the right way, you don't want to accept that. Or worse yet, you're teaching 1, 2, 5, 10, 20 other people the wrong way to be doing something.
Yep. It's a big web, and it can get a lot of people confused.
Absolutely.
So, David, I know you've got some good information on things that show up in our industry as far as supporting cables and there's a right way and a wrong way to do it that the standards talk about, and I think you've got some good information on that.
Right, I appreciate that. So when you look at the standards and the codes that are out there, standards are important guidelines for the installation. And when we look at, how's a category cable or a fiber optic cable, how are they manufactured? What parameters are they designed to? And in the case of copper, the cable manufacturers will design and manufacture their cable to utilize a 4 times maximum OD bend radius, if you will. So if you have a 1/4 inch diameter cable, you need a 1 inch radius for that. And believe it or not, a lot of people will mix up the difference between a radius and diameter. And a radius is half the diameter. So when you'd be looking at that, you'd be looking at 2 inches. The other thing that is, and it's here on the screen, is not all manufacturers of, in this case, non-continuous supports or even continuous supports. So an example of non-continuous supports would be like a J-hook. And Caddy introduced the highly engineered J-shaped piece of metal back in 1995. This happens to be one of the originals. And it was great for Cat 5e cabling all day long. But as the performance increased, the diameter of the cables increased. It was really important for us, and the manufacturing industry actually came to us to design a new J-hook that would be able to have a better bend radius support to move forward. And that's when we introduced what we call the CAT HP J-hook. And so we made it significantly wider in all sizes than the original J-hook. But more importantly is that we changed the geometry of the edge. While the older generation was good, the one that we have currently fully meets all the requirements of today's cabling and far into the future. If you look at the slide that's on here, what we did here is that we used a Mitutoyo contracer device, which would measure what the bend radius would be, or the capability of various manufacturers of support. And we're not going to identify the manufacturers out there, but the one at the top is the Invent Caddy J-hook, and you can see with the green that it has an extremely good bend radius support and capability built within it. Conversely, some of the other ones that are out there, and there are some good ones that meet the needs, but there's several that just flat out don't. And Chuck was talking about a bundle of cable. What we did in this situation is that we took a bundle of 60 Cat6 cables. We left them in for just 24 hours. And we did put in a sag of 12 inches, which is the industry maximum, if you will, of sag between the supports, 5-foot supports. And if you look in the second picture down, look closely, you'll see that all the bottom cables there had an indent on them from that particular manufacturer. And several of these have that situation because their edges are really sharp, if you will. And one of the comparisons that I make to it, we all know that bridle rings are not accepted as an approved method of support because it doesn't provide bend radius, nor does it have the wide base of support. And it's two factors that you got to look at there, not just one. But in some situations, the bridle ring actually has better bend radius support than some of the examples that are out there. So it's really important when you're looking at bend radius support to consider that.
Yeah, that's actually scary seeing those indents in there, because that will show up on a test, and we'll show an example a little later on of that right there will certainly give you some crosstalk on that cable, and it'll show up, and with your tester you'll be able to pinpoint where along the cable excuse me, that problem happened.
Right. And Steve, back when you were only running the gig or only concerned about 2-pair, it wasn't really a big deal, or as big of a deal, so to speak. But now, when you're looking at 10 gig throughput, you're using all 4 pairs. So you got to look at the geometry of the pairs and the effects that you are putting on them, like that buttermilk cable. But now we also have this new technology, this little thing called PoE. And it's obviously growing exponentially and being utilized for high wattage throughput to power lights and TVs and projectors and wireless access points and so on and so forth. And again, anytime that you have those types of indents, it has the capability of affecting the performance. And that's just what you don't want to do. This was just after 24 hours. Think what it is a year down the road.
Yeah.
So it's not just the immediate testing. What about a year down the road when the cable is settled a little bit more? Is that going to change with time? So these are things that you and the testing community can look at and weigh in on.
Yeah, and you're right. Over time, the temperature rises and falls in the space where the cabling is. That weight, it adds more and more of an indent, and that indent not only changes that geometry of the pair and impacting the crosstalk, but when you change the geometry of a pair, if you're in a sense, it's a solid copper conductor. Each of those conductors is a solid copper conductor. When you start bending a piece of copper, you change the resistance of that piece of copper. And now you're going to have a problem with resistance unbalance. And that's one of the big things that we test when we're looking at cables is how balanced is the resistance between the two conductors in the pair, and how balanced is the resistance between one pair and every other pair in that 4-pair cabling. And that's critical, as you mentioned, for PoE, because if you have an unbalanced situation, that's, first you're going to have data issues because you're crosstalk, but you've got unbalance in the pair now. Or worse, it has enough to actually sever a conductor if it's that much weight over time. Now you've got bigger problems. You're not going to get that PoE to the endpoint, and your data is not going to be getting where it needs to be.
Yeah. Well, one thing you haven't really talked about is you're talking about, okay, that bundle of cables over a period of time. A cable plant lasts 7-10 years, sometimes even longer. The customer's going to add cables to that, and so the weight's going to get heavier, and it's going to damage it even more. So that, you got to think about. So always when you think about your pathways, always think about adding stuff to it. Always go more than what the customer needs at that time, because it's easier to put the stuff in during construction than coming afterwards and try to open up a bunch of ceiling tiles in an existing office space to put stuff in.
Yep.
Steve, one other consideration to think about, in the previous slide, we talked about non-continuous supports like J-hooks and that type of thing. From a continuous perspective, we've taken the same concept and looked at the wire basket tray in this case. And, we've looked at, if you think about the rods that are used within wire basket tray, basically you're looking at a bridle ring, if you will. And now they're typically set up on a 2-inch by 4-inch cell, what I would call a cell, but still the cable is resting on, in essence, a bridle ring. So what we here at Caddy WBT have done is that on the cable support rods, if you will, we actually will flatten them out. Think of it like a hot dog versus a piece of bologna, so to speak, a little similar in that regard, but it does create a significant amount more of surface area of support than does just a simple conductor, single rod, round rod, if you will, for cable support. And it's somewhere in the neighborhood of about 400% more surface area of support. And so you have the much less chance of pinching that cable, particularly if you start loading the tray down. And we know that, as time goes by, we know that contractors do not ever throw more cable into the tray after the initial installation. So, but you really got to look at the future and trying to minimize as much as possible any negative impact, particularly on the bottom row of cables within the tray.
Yep. You always have to consider that worst case in there.
Exactly.
Yeah, you could pile cable on. Oh, look, it looks so nice from the top. Well, you look underneath, it's not so nice anymore.
Absolutely. So this is becoming, very popular for us. This is proprietary to WBT, but we can manufacture both. But the shape tray, as we call it, is becoming very, very popular.
Installers are getting better at identifying these areas and selecting better products, like David's talking about. But one area that I see that they miss a lot, the cable bend radius coming out of ladder rack and all that stuff. But one area I always see that they miss, and it drives me crazy, is when you have a sleeve coming through a fire rated assembly. You got 400 cables coming out of it, and they come out and do that 90 right out of it. Well, those cables on the bottom are going to get crushed.
Yeah.
And they make devices for that to help keep that bend radius smooth so you don't kink those cables.
Yep, that's a good point. It's like you if you're pulling cable through a conduit, you don't want a very sharp 90 in the conduit, right? Same thing coming out of a sleeve like that. You don't want to have it just waterfall out.
Think about your telecom rooms, right? Because the fire stop sleeve just comes through 1 to 3 inches. And then they route the cable down the wall, so that cable does that 90, comes right down. Those cables on the bottom are going to get crushed.
Yeah.
You don't want your cable getting kinked, crushed, stepped on, cut, or burnt. And I did say burnt. I've seen it in the field.
Yeah.
So that's very true. So that's one of the things that we really concentrate on a lot in our manufacturing is really trying to keep it to the standards. If you think about it, we're literally on our second or third generation of a cable support of the J-hook design, and there's reasons for that. I mean, we have a lot more sensitive cabling than we did in 1995. So it's critical that manufacturers like us evolve and make new products, new designs that meet the needs of the industry more effectively.
And I imagine, like us, you guys take a lot of feedback from customers in the field as they use the products, and they give you input on things they might like to see, or situations they encounter that maybe weren't previously considered, or maybe are totally new as things have changed. And I'm sure that you guys take that back to your R&D team and go, hey guys, we need a solution for X.
Absolutely. And in fact, we're in the process of introducing a updated design of our J-hook style right now. The cable support aspect of it hasn't changed because it's still really good and meets all the needs, but we've changed the neck of this part, if you will. And the changes that we did, and it's interesting to get feedback from the field, voice of customer, VOC, back from our contractor base, installer base, and we've listened to that. And it was interesting in the old design was that the contractors, when they wanted to take this and install it on the ceiling, they would simply take a pair of alignment pliers, take it and bend the neck, and now they could go right up to the ceiling and fasten it. With our new design, original design of this J-hook, the new style, it was made, it had multiple contractors tell me, we made it too strong. When have you been told you've made something too strong?
Because they couldn't bend it now.
Exactly. And so what we did with the new design that we're just literally now introducing, and we're doing this with the most popular size, which is the 2-inch. We'll be extending that into our other sizes shortly. But we went ahead and made the notches that are here in the neck. And this allows you to be able to go ahead and, let's say, put it to the ceiling, either shoot it or bolt it to the ceiling, and then you're going to bend it down. So now you can have a situation here where it's still affixed firmly to the ceiling, but now you've got one SKU that's doing two different applications. Conversely, or in addition rather, a lot of times you need to go on a 1/4 or 3/8 rod. So we can still do the same thing. We can go ahead and put it on the threaded rod, and then we simply bend it the other direction, and we'll have it mounted that way. So now the one SKU can do 3 applications without any angle brackets or anything like that. And very importantly, it maintains the UL aspect of it. When they bent the old style, they ruined the UL certification because we didn't certify it to that. This has been designed now to, go flush to the wall, to be able to be bent either way and still maintain the UL certification for application, and still maintain the 60-pound UL 2239 rating of that at 3 times load testing. So it still maintains the 60-pound load.
I want to highlight something for a second because most people are going to miss this. Your estimators and your project managers are going to be really appreciative that it has 3 functions, because that's one part on a bill of materials. That's one line on a bill of materials that a project manager has to manage. It makes their job a little bit easier.
It's and one other thing that we didn't do, and that you're absolutely correct there, I was a little hesitant, and I'll be honest, I was a little hesitant to maintain the same part number for this. And so we went out and I started asking contractors, do you want us to change the part number? And it was like, no. So the part number is not going to change. This one happens to be the 2-inch. It's a Cat 32 HP. It's just a running change that we're in the process rolling out literally right now. And so the new 2-inch J-hooks that we're shipping out will be all the Versa mount is what we call it. And so it'll all be the new style J-hook as the inventories within ours and our distributors get flushed out.
Man, that's cool. It's good to see that kind of response to customer feedback. That's, with us, we do the same thing. In fact, I'm like the funnel for the VOC stuff. And I work closely with our engineering team at our innovation lab. And I take that feedback and provide it to them and work with them and work with the customers to see what we could do to make the products better. And I mean, the tester, and I'm going to pull up my screen here because I want to show you a quick test where we can see, I'll show you some crosstalk on here. So we can see what could happen if you don't have the proper support and you get a crushed cable, and you can see that crosstalk. But the tester that we've got today is night and day from what it was when I joined the company almost 4 years ago. And it's because of that customer feedback. So it's good to see, another company like this that takes that feedback and the experience from the customers and makes it, a better product out of it. So I'm going to share my screen now.
Yeah, I was putting on my safety glasses so I could see the screen when you put it on. These are not reading glasses. They are ZL1 safety glasses.
Yep. So I'm going to, for some reason, my screen's not sharing. Not sure what's going on here. Let me see. I'm not able to share my screen. We may have lost control. All right. For some reason, we're not able to share the screen. So I was going to show tests, but you guys have seen, we've had other episodes where we can see crosstalk. And when you run a test, what will happen is if it fails that crosstalk, the tester's got a TDR trace. It'll show you where that crosstalk is, or if it fails return loss, or if you have a shield problem. And you can see how far out on the cable, how many feet away or how many meters away that problem is. So in a case where you've got a cable support issue, where it's being pinched, that you can see that it'll be a spike on that crosstalk trace when you look at that TDR trace. If it's a damaged cable, you can see crosstalk, you can see shield damage, all those things can show up. So I apologize that we weren't able to share the screen. We've had a little glitch with the Restream app we're using, I guess. But so I think that just about wraps it up. Oh, pardon the dog barking in the background. Somebody just rang the doorbell here. Live show, folks. So again, appreciate Dave, you and Chuck joining me today. Fantastic topic. I think a lot of people think if it's not technology related, then we're not talking about. Well, we want to talk about everything, because everything we do in this industry impacts the end result that the end customer gets in that cable plant. So I think this is a really good episode, and I appreciate you guys joining us, and appreciate everybody who is in attendance today.
Thanks for having us on.
Thank you very much.
All
Appreciate
right.
it, Steve.
Thank you, guys. All right. Take care now. And we could probably just click the leave button.
It's the big red button at the top.
Yeah. I think the app had a glitch, so we'll just click the leave button and say goodbye.
All righty. Take care.